Your lecturer is Professor James A. Sellers. Dr. Sellers is Professor of Mathematics and Director of Undergraduate Mathematics at the Pennsylvania State University. His engaging teaching style has earned him a wealth of honors and distinctions. These include the Mathematical Association of America's Allegheny Mountain Section Award for Distinguished Teaching and Penn State's Mary Lister McCammon Award for Distinguished Undergraduate Teaching.
Hello, and welcome to the Teaching Company's Algebra 2 course. My name is James Sellers, and I look forward to working with you as your Algebra 2 instructor throughout this course. As we begin this course together, I'd like to do a number of things. First, I'd like to introduce myself to you. I'd like to introduce you to the general topics and themes for this course. I'd like to share a number of other thoughts about things like graphing calculators and other things that will help you to work through this course. And I'd like to begin our mathematical conversation with a review of order of operations as well as laws of exponents. So let me begin by sharing a few details about me. I received my PhD from the Pennsylvania State University in 1992. While I was a student at Penn State, I met my wife, Mary. And in 1992, when I finished my PhD, I moved on to my first teaching position at Cedarville University, which is in Ohio. After 9 years at Cedarville, I went back to my alma mater, Penn State, and in 2001, I became the director of undergraduate mathematics there. My wife, Mary, and I have 5 children, one of whom is now a student at Penn State. 2 are in high school, 1 is in middle school, and 1 is finishing up her elementary school years. For a number of years, we've homeschooled our children, although several of them are now in schools, but we've really enjoyed working with them one-on-one at home as we've taught them mathematics and English and a variety of other topics. I've also spent time writing texts, especially secondary level texts, for a number of companies, the main one being Saxon Publishers several years ago. I love to teach. It's something I've enjoyed for probably more than 20 years, and I hope you'll notice by the time we've completed this course together that it's a real joy for me to teach and to work with you on this algebra material. So, what's this course about? Well, in a nutshell, this course will include a number of topics from the usual high school Algebra 2 course. But it's important for me to note that we can't cover all the topics that would be taught in a high school Algebra 2 course. After all, we've only got 18 hours of lecture time together. But I'll try to talk about a variety of very important topics that would appear in the usual Algebra 2 course. So here are some of the things that you and I would discuss throughout this course. I want to start with just some prerequisite basics, things like order of operations, laws of exponents, solving linear equations, principles of graphing, asking the question, what does a function look like and how do I detect one, and so on. And after we've covered these prerequisites for a few lessons, I want to move on to solving systems of linear equations and inequalities. From there, we will move on to quadratic equations and quadratic functions. And that sounds kind of big and lofty, but it's just degree 2 polynomials. And we'll spend several lessons on quadratics. It's a very, very important topic in any Algebra 2 course. From there, we'll talk about things known as conic sections because they're very, very closely related to quadratic equations. And conic sections are just things like parabolas and hyperbolas and circles and ellipses. After we've dealt with those quadratics for several lessons, we'll move on to polynomial equations and functions, especially as they relate to things like factoring and graphing and even finding the zeros of a polynomial function. Now from there, we move on to other types of functions, and these can include power functions, or what we might call root functions, like the square root or the cubed root function. We'll also talk about rational functions, including how to graph rationals, how to combine them with the usual operations of addition and subtraction, multiplication and division, and we'll also talk about something really neat called composition of two functions. And we're also going to talk about one of my favorite topics in an algebra course, partial fractions, which are extremely important not only in algebra, but also in later courses, including calculus. After that, we'll talk about exponential and logarithmic functions, and then we're going to close with some of my favorite mathematics. We'll talk about combinations, permutations, and a little bit of elementary probability, because all of these things relate to something called the binomial theorem, which beautifully connects algebra to combinatorics. Now, within each of these general topics that I just shared with you, we're going to concentrate on several strands or themes. And these would include things like the following. We're going to always want to master the basics. Mathematics is a very step-by-step process, and understanding how to handle basic steps one at a time allows us to build the course beautifully, and it also allows us to master the material. So we will constantly think about how we can master the basics one step at a time. I also want us to talk about graphing a lot. Mathematics is often thought of as symbol manipulation, and I think this is unfortunate. We want to talk about being able to see the mathematics as well. And so we will talk about graphing and how to visualize graphs throughout this course. We're also going to spend a lot of time focusing on functions and defining things like domain and range and really understanding what a function is in this course. I think that's very important as we go into Algebra 2. And lastly, I want to make sure that we think about the strand of critically thinking about our solutions. After one gets an answer in a math course, it's very, very important to ask, does this answer make sense? Does it really answer the question that was given to me originally? And so on. So we'll talk about critical thinking as we walk through this course together. Now, one of the most natural questions that you should be asking as we start this course together is, why is algebra important? Well, let me try to answer that in several ways. First of all, high school algebra is the prerequisite course for all other higher level math courses, including things like trigonometry, pre-calculus, and calculus. And to be honest with you, my hope is that this will not be your last math course, that you'll use this course as a stepping stone for future courses. So one of the reasons algebra is important is because it's a stepping stone for things like trigonometry, pre-calculus, and calculus. According to several studies that have been conducted in recent years, students who master Algebra 1, geometry, and Algebra 2 are much more likely to succeed in college-level mathematics. So our algebra foundation is very, very important. But why is algebra important in its own right? Well, I could share lots of different answers with you, but let me just say this. Algebra is extremely important in a lot of problem-solving situations. Being able to go to the abstract from just basic arithmetic allows us to solve tons of real-world word problems. And without algebra, there would be no calculus. And without calculus, much of what is done in physics and engineering and related areas couldn't be done. From designing machinery to electrical circuits, none of it would be doable without calculus. So you probably have lots of questions that we should ask and try to answer before we really get into the math of this course. So let me try to ask some of those questions and to answer them as well at this time. So one question you might have is, will this course require a certain calculator? This is actually a question I get all the time at Penn State. Let me answer that question by sharing a bit of philosophy on calculators with you before I try to answer your specific question. I think calculators can be very useful, and I use one all the time. But I fear that students sometimes are allowed to rely on them too much. And because of this, I will not focus on calculator usage in this course. If you'd like to use one, especially as we try to look at the various graphs of functions that we'll see in this course, that's fine. Otherwise, you'll probably rarely use one with me in this course. So you don't need a specific calculator as we walk through this course together. Okay, another natural question to ask would be, what's the textbook for this course? Well, I can answer that one pretty easily. I don't have a particular textbook to suggest for this course. There are lots of different Algebra 2 texts on the market today, many of them with titles that say Algebra 2. I would encourage you to supplement the work that we do in this course together with any of these Algebra 2 texts that are on the market. The workbook that accompanies these lectures is meant to serve as a beginning guide. If you want to supplement that workbook with a larger text in Algebra 2, please feel free. Now, with that workbook in hand, you should be asking, how do I use that workbook with these videos? And that is a really good question because there are lots of different things you could do with these resources. Let me just make one suggestion. I would suggest that as you begin a new lesson, you briefly read over the material in the workbook first. Then put the workbook aside and start the lesson on the video. Once the lesson is done, and I've completed that lecture, I would then return to the workbook, reread the material a second time, and then work through the exercises that are at the end of the lesson in the workbook. It's extremely important that you do those exercises at the end of each lesson because by practicing, you're going to learn the material better, you'll master those basics that we've talked about already, and you'll be ready to move forward to the next lesson. Now, one of the best ways to learn math is by doing it. That's what I was just saying. And in this course, you'll get to try some of the problems on your own before we work through them together in the lesson. So apart from the problems in the workbook, you'll even have the opportunity during the lesson to work through some problems. And even if you make some mistakes as you're doing it, you'll learn the material faster and better if you actually work through or solve the problems than if you just sit back and listen to me and watch me do the problems. So I want to encourage you as we're working through the lesson together that you work on the problems before me and see if you get those answers even before I work through the steps. So grab a pencil, grab some paper, and be ready to stop the video when you see this certain cue on the screen. Once you think you've got the answer, start me back up, get the lesson going again, and we'll see how you did. And in some ways, you'll be able to check your answer at that point. So, with that as an introduction to this course, I'd really like us to get going with some actual math. I think we should do some math today. And so, let's get started with the topic of order of operations. So, as we work together, we're always going to have to worry about adding, subtracting, multiplying, dividing, even doing something called exponentiation, like taking 2 to the third power or something like this. And it's very important that we know in which order we must complete those operations. And so we have these things called order of operation. And in today's examples, I want to focus on order of operations issues just in arithmetic. So basically adding, subtracting, multiplying, and dividing just numbers, as well as raising numbers to powers. Like I said earlier, taking 2 to the third power. We'll also have to deal from time to time with having mathematics inside parentheses. And we need to know when to do the work inside the parentheses versus when to do the work that's outside of those parentheses. So these concepts on order of operations will be very important not only when we're manipulating numbers, but also when algebraic expressions, variables like x and y, come into the picture. So here are a few basic ideas that we must always remember. In simplifying a complicated expression that has parentheses and exponents and additions and subtractions, multiplications and divisions, we have to do them in this order. And that's why we call it order of operations. The first thing we have to do is always work on what's inside parentheses first. If the problem has a set of parentheses in it, you must do the material inside the parentheses first. That's the wisest thing to do, and it's the correct thing to do. Secondly, as you read the problem from left to right, you must perform all of the exponentiations later. That's a big word. I simply mean perform the operations where one thing is being raised to the power of another thing. Again, like 2 to the third power equaling 8, or 3 to the fourth power equaling 81. So we've done what's inside parentheses, and we then compute all of the exponentiations. The third step in the order of operations is, again, reading from left to right, perform all of the multiplications and the divisions that we see. So if you see any numbers being multiplied by each other or divided one by the other, we need to do those next. And lastly, we want to perform all of the additions and subtractions. And again, we need to do them as we read them from left to right. So that's the set of order of operation rules, if you will. And now let's put these into practice. So to do that, I want you to try the following first on your own. Let's compute 10 plus 7 minus 5 plus 3 minus 18 plus 25. So here's the cue. Stop the video now. When you think you've got the answer, start it up again. So how do we solve this? Well, we see a mixed set of additions and subtractions. We're going to read from left to right, and we're going to work through the operations one at a time. First, we see that 10 plus 7 is 17. And then we take the 17 and subtract 5. 17 minus 5 gives me 12. 12 plus 3 is then 15. 15 minus 18 is a negative 3. And negative 3 plus 25 is equal to 22. So my final answer is 22. And now I get to ask you, did you get that answer as well? I hope you did. And if you didn't, it's okay. We're going to keep working through some more examples, so don't worry. Let's see if you can get this one. I want you to compute 7 times 4 divided by 2 times 3 divided by 6. The cue tells you to stop the video and work the problem for yourself first. You'll learn a lot more doing that. Okay, now let's solve this together and let's see how you did. Just like with addition and subtraction, problems that have a mixture of multiplications and divisions should simply be computed left to right. So let's work through this problem together. We've got 7 times 4 divided by 2 times 3 divided by 6. So the first thing I'm going to do is 7 times 4, that's 28. So now I have 28 divided by 2 times 3 divided by 6. I continue to work left to right. 28 divided by 2 is 14. So now I have 14 times 3 divided by 6. I keep working left to right. 14 times 3 is 42. And so now I'm down to just 42 divided by 6. And that one's pretty straightforward. I get 7. So hopefully you got 7 as your final answer as well. Okay, so far so good. Now let's complicate things just a bit. I gave you a few examples where we had some additions and subtractions, and then we had some multiplications and divisions. Now what I want to do is mix these up a little bit more together. So let's do the following example. I want to look at 10 divided by 2 minus 3 times 5 plus 7 times 2. Now, my question to you is, according to the order of operations, do we just start on the left and work our way over to the right side? No. You have to remember that multiplications and divisions always take priority. They always get done before additions and subtractions. So we're going to multiply and divide everything first, then we'll add and subtract. So see if you can do it now. Stop the video and see how you do. Okay, so how do we handle? Well, first we're going to work left to right doing all the multiplications and divisions. And by the way, I don't mind if a division is first and a multiplication is later. Multiplications and divisions have the same priority. So I'm just going to work my way left to right and handle all the multiplications and divisions. So the first thing I see is a 10 divided by 2. I'm going to compute that, and it's going to then give me 5. So my problem is now 5 minus 3 times 5 plus 7 times 2. Now, as I'm reading left to right, I want to skip over that subtraction and move to the multiplication that I see, because I have to do multiplications before I do any subtractions. So I'm now going to compute the 3 times 5. And when I do, that gives me 15. And so now my problem is 5 minus 15 plus 7 times 2. Now I see a subtraction, then I see an addition, and then I see a multiplication. The multiplication must be done first. And that's the 7 times 2. So I'm going to compute that and give myself 14. And now my problem is 5 minus 15 plus 14. And now notice we've taken care of all the multiplications and the divisions, and we're down to just one subtraction and one addition. And those guys can be done just left to right, starting with the subtraction. And when I do 5 minus 15, I get negative 10. So I have negative 10 plus 14, and that's equal to 4. And that's my final answer. And if that's the answer you got, then you're doing a great job as we walk through this. And by the way, let me point out before we do the next example that we were just doing basic steps. Did you notice how we just took it one step at a time? It's extremely important as you do math, even when we get some really big looking problem, to just pause, do things one step at a time, and before you know it, you'll have the answer. It might take a moment to write it up on a piece of paper, but you'll get to the final answer as long as you follow those rules and master those basics. Now, let's do one more example of the type that we've been doing. I'd like you to try it yourself first. Here's the problem. 10 minus 5 times 8 minus 2 plus 17 minus 13 times 2. Now, let's solve this together. Well, I'm going to read left to right. I'm going to look for all of those multiplications, and if there are any divisions there, I want to do those first. Of course, first I should have been looking for parentheses, but there aren't any. And secondly, I should have been looking for exponentiations, but there aren't any of those either. So now I need to look for multiplications and divisions. And as I read from left to right, the first one I see is 5 times 8. And 5 times 8 is 40. So my original problem is now 10 minus 40 minus 2 plus 17 minus 13 times 2. Now I start reading left to right again. I'm going to skip that subtraction. I'm going to skip another subtraction and an addition and a subtraction, and I'm going to get to a multiplication. And I see that 13 times 2 sort of dangling on the end. It has to be done first before the additions and subtractions. And 13 times 2 is 26. So now I have 10 minus 40 minus 2 plus 17 minus 26. And everything that's left is just a subtraction or an addition. So I can just march through those one at a time, starting on the left and working my way through to the right. So I have 10 minus 40, that's negative 30. Minus 2 gives me a negative 32. At that point, the problem is negative 32 plus 17 minus 26. Negative 32 plus 17 is negative 15. And when I take negative 15 minus 26, I get negative 41. And that's the final answer. Now, we've seen how to handle mixtures of additions and subtractions, some multiplication and division operations all together. But of course, I haven't thrown any exponentiation in yet, and we really haven't had any parentheses either. So let's look at an example with some exponentiation. Now, remember, exponentiation really is just repeated multiplication. So what I mean by that is that if I take 3 and raise it to the second power, 3 to the 2 is just 3 times 3, and 3 times 3 is 9. And if I take something like 2 and raise it to the fifth power, it's just 2 times 2 times 2 times 2 times 2. And if you multiply all those 2's together, you'll get 32. Remember that exponentiation is just repeated multiplication, and according to the order of operations rules, exponentiation has to be done before multiplication and division. So let's look at an example now with some exponentiation. I want us to compute 5 plus 3 times 4 raised to the second power. Okay, the first thing that we have to do is the exponentiation. Even though as you read from left to right, it's way over on the end, I still have to do exponentiations before I do multiplication or addition. So I have a 4 raised to the second power, that's 16. So my original problem is now 5 plus 3 times 16. Next, I want to do the multiplication, because multiplication takes priority over addition, and 3 times 16 is 48. So my problem now is 5 plus 48, and of course I finish by doing the addition. 5 plus 48 equals 53, and that's the final answer. And I hope that you got that even before we did it together just now. Now, there's one last thing to consider with order of operations, and that's parentheses. Anything inside parentheses always gets solved first. Remember, that was part of the order of operations rules. So, I want us to try an example with just a little bit of parentheses thrown in. Here's the problem. 10 minus 5 times the quantity 8 minus 2 in parentheses, plus 17 minus 13 times 2. Now first we have to simplify the 8 minus 2 that's in the parentheses and write that as 6. 8 minus 2 is 6. And now the problem becomes 10 minus 5 times 6 plus 17 minus 13 times 2. Now I don't see any exponentiations. That's what I would have to do next in my order of operations rules. So I skip to multiplications and divisions. Notice how it's just the same thing over and over. And if I do that starting from left to right, my problem is going to convert to 10 minus 30 plus 17 minus 13 times 2. And of course that 13 times 2 is 26. So now the problem is 10 minus 30 plus 17 minus 26. Well, now we're down to just additions and subtractions. So we just march through them going left to right, and we can do subtractions before additions if we need to. The point is just to do them from left to right. So 10 minus 30 is negative 20, giving me negative 20 plus 17 minus 26. And negative 20 plus 17 is negative 3. So now I have negative 3 minus 26, and when I combine those two, I get negative 29. Notice that when the same example was completed earlier in this lesson, when I didn't have parentheses, the answer was negative 41. You may or may not have noticed that I just changed those two examples a bit. Here we got negative 29 as the answer, and those parentheses make a really big difference. You always have to compute whatever's inside the parentheses first before you do anything else. Now, I'd like to talk a bit about one other important mathematical topic as we close out this lesson, and that's the concept of laws of exponents. Now, throughout this Algebra 2 course, we're going to need to remember these laws. They're going to show up over and over again. So let me remind you of them today, and then as we need them, we're going to use them over and over. So there are 3 laws of exponents we need to remember. First, if you have x raised to the a and you multiply that by x raised to the b, it's the same as just doing x raised to the a plus b. So the exponent becomes the sum of a and b. The second law is x to the a divided by x to the b equals x to the a minus b. And lastly, if you take x to the a and then raise that to the b, it's the same as x to the product a times b. So let's see if we can solve a few examples quickly of this type. I want us to take 2 to the 5th times 2 cubed. I want us to get 4 to the 9th divided by 4 to the 3rd. Let's also compute 3 to the 2nd divided by 3 to the 8. And then let's do 2 to the 7 and raise that to the 3rd. And lastly, I want us to compute negative 2 raised to the 3rd power and then raise that to the 4th power. Now, did you get the answers that we needed to get? Let's see. 2 to the 5th times 2 to the 3rd is 2 to the 5 plus 3, which is 2 to the 8. 4 to the 9 divided by 4 to the 3rd is 4 to the 9 minus 3, which is 4 to the 6th. If I do 3 to the 2nd divided by 3 to the 8, I get 3 to the 2 minus 8. And one way to write that, of course, is 3 to the negative 6th power. Some folks like you to rewrite that as 1 over 3 to the positive 6th power. We can talk about that some more later, but either of those answers would be fine. 2 to the 7 to the third is 2 to the 7 times 3, which is 2 to the 21. That uses the third law of exponents we saw before. And lastly, negative 2 raised to the third raised to the fourth is the same as negative 2 raised to the 3 times 4, which is negative 2 to the 12th. And since 12 is even, that's just 2 to the 12th, and the negative sign gets canceled. Well, today we've learned about the basic structure of this course. I've talked a bit about some of my philosophical views of it. And we've started our mathematical journey together with a discussion of two things: order of operations and laws of exponents. Next time, we'll continue our review by talking about solving linear equations. I'll see you then.